Okay, so this is a talk on advanced techniques for building container images, or more accurately, the sort of build kit tool, and that's available in newer versions of Docker. And I think a lot of people aren't really aware of this, and it could be helpful to a lot of you, so I thought I'd give a quick talk on it. There have been traditionally some problems with sort of Docker builds. There was quite a simplistic caching model, which could be slower than necessary, and also requires root to build images, which is really annoying if you want to do a build on a server, for example. Other than that, there's also problems with secrets. So if you want to get like an SSH key or something to use that during a Docker build, it was far too easy for that to end up in the actual final image, which is a big problem. Also, Docker stopped developing the Dockerfile syntax at some point, and it's only kind of recently that we've fixed a lot of these problems in BuildKit, which is a fundamental rewrite of the sort of Docker build backend. It is still a client-server model, so you're still typing Docker build on your client, and it's going off and building on a daemon or a BuildKit instance. But the big difference is it now uses something called LLB, or low-level builder, which is like this intermediate format, something like LLVMIR or .NET CIL or Java bytecode. The big thing about LLB, though, is it's no longer this sort of a linear Dockerfile way where everything moves in a simple sort of chain, and you have to have done the point above before you can do the point below, and so on. So we've moved from that to like this directed acyclic graph model, which potentially allows some parallelism. So in this example, you can see there's and this is from the BuildKit repo, you can see there's various places where things can happen at the same time, and by doing that, we obviously can get faster builds, hopefully. To take advantage of that parallelism, though, we do need new front ends. And this is the stuff that compiles down into LLB, because you probably don't want to write LLB directly. There is a Dockerfile front end, and there's a handful of others, but we're going to need some new ones around various tool chains before we can really take advantage of the parallelism in LLB. Okay, so let's go look at BuildKit. The thing you can do today, if you're in Docker 1903, is type export docker buildkit equals 1, and you'll immediately get sort of this new output format. And just by doing that, it's kind of an advantage, because you get sort of nicer formatting and timings for each step, etc. But you can take it further, and we can start using the new sort of syntax stuff that's available. So we tell it we want to use the Dockerfile front end by adding that to the top of the Dockerfile. And then we can start using some of the new features. My favorite one is actually the mount options, especially the cache mount option. So the cache mount option basically says for a run command, I want to use this sort of volume as a cache. And that's really useful when you've got like a Go, a compiler, like a Go compiler or a C compiler, because if you're doing multiple Docker builds, it can reuse that cache, and so your subsequent builds can be faster and have quite a big effect. You do it by typing this sort of -- mount equals type cache and telling the directory you want to cache, and then your normal make or go build command. Another good one is the secret in the SSH one, so we can get secret data in via this mount option without leaking it in the final image. Again, it works in pretty much the same way, except we do -- mount equals type equals secret. Yeah, and in this case, we're using it to put in the credentials for AWS, so we can download data from an S3 bucket. We do also need to hand the flag to Docker build, so Docker build knows where to find the credentials. Another nice thing, output formats. We don't always want to get an image as the final result of a Docker build. We may want to get a binary if our image is a compiler, or perhaps we've got like a LaTeX container that builds our PDF document or something. And so we actually want to get a PDF out at the end and not an image. This used to be a bit of a pain. You'd have to do something like Docker build, then create a container and copy the artifact out of the container. But now you can kind of do it all just in the Docker build command by using this output format stuff. So at the end of the Docker file, you'll do something like this. And I'm copying like the artifact that I want out into a Scratch image. And so I've copied, from the previous example, I've copied the binary into the Scratch layer. And then the next thing I'm going to do is at the build time, I'm going to tell it I want to pass the output flag and tell it type equal local and destination be the current directory. And when I run this Docker build command, I will get the binary out in the current directory all as one step, which is quite nice. There's a bunch of other stuff I would like to talk about, but this was a 5-minute talk, so I couldn't really. But you might want to look up Docker build X and builder instances, multi-platform builds, so you can build for other platforms on the one your laptop or whatever, and bake, which is like make for Docker files, and really quite nice. If you want more information, I do have a longer version of this talk you can find there, but probably the best one is the DockerCon talk by Tonus, because Tonus was the guy that wrote all this BuildKit stuff. The only thing with that one is it's pretty technical. Yeah, and there's some stuff in Mockify on the GitHub repos, etc. Okay, thank you.